We're busy looking at limit laws and how to use the limit laws to calculate limits algebraically. So let's carry on. Here we've got the limit as x approaches -2 of this given function. Now you can quickly see that if I just simply substitute -2 in, my denominator will be 0, so that is not allowed. So we need to see if we can manipulate this function a little bit so that we can substitute in. So I've got the limit as x approaches -2. Now my denominator we can easily factorize, x minus 2, x plus 2. The numerator we can factorize, that is x plus 2, 2x plus 1. Let's just check, our middle term is 4x plus 1 plus x is 5x, that works out. All right, now like we saw in the previous video, that this limit is the same as the limit as x approaches -2 of the function 2x plus 1 over x minus 2. Now take note, these two functions are not equal because the first function is not defined at x equal to -2 where the second function is. But around -2, they behave the same way. Now I've got this limit in a form where I can substitute in. So if I substitute in x equal to -2, then we've got our limit value. So if x is equal to -2, I've got -4 plus 1 is -3, -2 minus 2 is -4, so I've got 3 over 4. Next one, same problem. If I substitute x equal to 1 in, what happens is we've got a denominator of 0. Now, interestingly enough, we've only been looking at the denominators, but if you look at the numerator, you will see the numerator, if I substitute x equal to 1 in, will also be 0. And you'll see the same occurring with the previous examples. So if you substitute in, now remember you're only allowed to substitute in if the denominator is non-zero. But if on the side and in your head you're substituting the numbers in and you see it's of the form 0 over 0, then you should go, all right, maybe I can factorize. And you will be able to factorize and do something if it's of the form 0 over 0. But if it's not of the form 0 over 0, then you probably won't be able to simplify it. But you can test that with the examples. So this is the limit as x approaches 1 of, now we need to do a bit of factorization of trinomials. We've got 2x, x, so we're going to have 2x, 5, and 1. So 2x plus 5, x minus 1, that will get me to 3x, there we go, and my denominator is x minus 1, x, and a 3, is it a plus or a minus? I need a plus 3. There we go. So then, now I know this function behaves exactly the same as the function 2x plus 5 over x plus 3. So yet again, the functions aren't the same, but they behave the same for values of x that are not equal to 1. So around 1, they behave the same. And now I can substitute in, and I got 7 over 4. So we intuitively look at it, we see, oh, I've got a 0 over 0 form, so I can substitute. But now, listen, do not write equals 0 over 0, because it doesn't equal 0 over 0. That is just something you do on the side, you look at, and then you know, well, I should be able to factorize it and then be able to calculate that limit. So let's make our functions a little bit more complicated. Let's look at this function. Again, a compound function, and we want to calculate a couple of limits. So let's start to look at the limit as x approaches -2. Now we need to take note, this function is defined at -2, but I'm not interested in what happens at -2, I'm interested in what happens around -2. And I've got different definitions for the function for values of x less than -2 and for values of x greater than -2. So what we need to do is we need to look at the limit as x approaches -2 from the negative side of this function, and the limit as x approaches -2 from the positive side. And only if those two approach the same number, then my limit exists. So let's take a look. As x approaches -2 from the negative side, that's x values less than -2. So this is the function we're looking at. So we're looking at limit as x approaches -2 from the negative side. My function is 2x over x plus 1. And now we don't have the sketch with us, but we can use the limit laws and our algebraic properties to see what happens. As x approaches -2, this function, I can simply substitute in, and I've got -4 over minus 1. So that's the value 4. So from the left, this function approaches the value 4 as x approaches minus 2. Let's see what happens as x approaches minus 2 from the right. Then we're looking at this function over here. So this is the limit as x approaches minus 2 from the right. And the function we're looking at is x squared minus x plus 2. It's a polynomial, so we can simply substitute in. So x is approaching minus 2. So I've got 4 plus 2 plus 2, which gives me 8. Now I notice that from the left and from the right are not equal. So I see that the limit as x approaches minus 2 from the negative side is not equal to the limit as x approaches minus 2 from the positive side of this function. So therefore the limit as x approaches minus 2 of this function does not exist. All right, so that one doesn't exist. Let's look at the next one. X approaches minus 1. Let's see what happens as x goes towards minus 1 now. What you need to notice is minus 1 is not on one of these changes. Minus 1 is just in there, between minus 2 and 1. So the limit as x approaches minus 1, I do not need to look at what happens from the left and from the right, because all around x equal to minus 1, this function value is x squared minus x plus 2. It's a polynomial, so we can substitute in. So we've got 1 plus 2, so that value is 4. So this limit exists and it's 4, because minus 1 falls in that interval. So if I look at x values very, very close to minus 1, we're simply going to look there. All right, now the last one is x approaches 1. Now again, this is where something happens. So now we see that this function is not defined at x equal to 1. But that doesn't matter, because we do not want to know what happens at x equal to 1. We want to know what happens as x gets very, very close to 1 from both sides. So I need to look at the limit as x approaches 1 from the negative side of this function, and the limit as x approaches 1 from the positive side of this function. Now, if we had the sketch, we could visually see what happens, but we're now trying to look at it algebraically. So if I look at from the left, we're falling into this interval, values of x less than 1. So I'm going to look at the limit as x approaches 1 from the negative side of this function, x squared minus x plus 2. That's a polynomial, so we can simply substitute 1 in. So it's 1 minus 1 plus 2 gives me the value 2. So let's look at what happens as x approaches 1 from the positive side. So those are values of x larger than 1. So this is the function I'm looking at, 4x minus 2. Yet again, a polynomial, I can substitute in 4 minus 2, that is equal to 2. Now I see from the left and from the right give me the same values. So I can conclude that the limit as x approaches 1 of this function is the value 2. And yet again, this is a piecewise defined function. You should at this stage know how to sketch it. So sketch that function. This first part might be a little bit tricky, but if you sketch that function around the value x equal to 1, you will see that from both sides I'm heading to the y value of 2.